Hi all, this is lecture 7. We're going to be in section 9.1 and 9.2, and we're going to talk about proportional reasoning and looking at more than one strategy. So proportional reasoning is really what we were doing when we used our boxes to answer questions. So when we set up our boxes and then said, oh, well, what if this total number is 24, and we figured out what the pieces were. So that was using proportional reasoning. But what we want to do is we want to then be able to move our students away from boxes into multiple other strategies. So here's what we're going to do. First of all, let's talk about the definition of a proportion. So a proportion is a statement or an equation, which means it has an equal sign, that two ratios are equal to one another. So we have been making that assumption along the way, but we want to state that with our proportions. So the quantities are then said to be proportional. So if I was writing this down, I would have something like, I don't know, A over B is equal to C over D, right? So I have two ratios, they are equal, and they have an equal sign between them, okay? Now there are four different strategies that we're going to talk about that involve solving a proportion that don't involve your boxes. And so we're going to take the example here where Steve and Mark were driving equally fast along a country road. It took Steve 20 minutes to drive 4 miles. How long did it take Mark to drive 12 miles? Now, the thing you're going to notice about all four strategies is they all start out exactly the same way. So we are going to create a chart that has 4 labels in it, and we're going to identify our values, and then we'll see what happens from there. So the first thing I'm going to do under factor of change, and we'll talk about why it's called that in a little bit, but I'm going to identify. So I'm going to have one fraction that represents Steve, or one category that represents Steve, and one that represents Mark. And then it talks about, for Steve, it talks about how long and how far he drives. So we talk about the number of miles he drives and the number of minutes that he drives. Okay. And so then I'm going to put the numbers that I know in the appropriate space. So we know that Steve drives for 20 minutes. So the 20 for Steve under minutes, and he drives 4 miles. So we put the 4 for Steve under miles. And then it would say, how long did it take Mark to drive 12 miles? And the thing that makes it proportional is that we know right here that Steve and Mark are driving equally fast along a country road. So that means that their speed is the same. So their miles per minute is going to have to be the same. So what that means then is that I want equal ratios here. Now you're going to notice here that there aren't actual ratios stated the way we would normally do in either fractional form or with a semicolon, but they are there hidden in the categories. So for factor of change, right, keep in mind they're asking us here, how long did it take to Mark to drive 12 miles? So they're asking for this quantity here. So to find the question mark, for factor of change, we're looking to say, how does one thing change so that I can make the other change in the same way? And it does not matter which direction you do this. So one way that you could go about this is to say, okay, well, in order to go from 4 to 12, I'm going to multiply this by 3. So I'm going to make the same factor of change down here. And that way, when you take 20 times 3, this gives you 60 minutes for Mark. Okay. Alternatively, let's go backwards. Instead, we could say, oh, well, I could go from 4 to 20. So this is times 5 in this direction. So the same thing here, 12 times 5 would also be 60 minutes. Right? So it doesn't matter which direction or which way you set up your labels, okay? As long as you have a change in multiplication, right? Factor meaning multiplication, and the change from one category to the next. So this is a factor of change strategy. Notice that we're typically multiplying or dividing by a whole number, so it's easy to think of. And there's no fractions involved here. They're just numbers that we're changing in the same kind of way. Okay, so that's what factor of change is. The next one is equivalent fractions. So I'm going to start this exactly the same way. So I'm going to start with Steve and Mark, miles, and minutes. But this time I want equivalent fractions. So I want a fraction for Steve and a fraction for Mark. And then I'm going to fill in my values. So we know that Steve, let's see, same thing from above. So Steve is 4 miles in 20 minutes. and Mark is 12 miles. Whoops. And we don't know how many minutes, right? And so what we're going to do is we're going to think about these as equivalent fractions. So if these two things must be equal, because they are proportional, and we know that their rates of change are equal, then we need to make an equal fraction by multiplying by the appropriate thing. So in order to change the numerator from 4 to 12, we multiply it by 3. And so down here, we would also multiply 3. So this would give us 60 minutes. Right? It's almost exactly the same way that you did factor of change going horizontally, only you have fraction bars involved, right? That's the only difference, is that we write the fraction bars. But this directly ties into the idea where you get an equal fraction by multiplying the same value top and bottom. Number 3 is a unit rate. So again, we're going to start out with the same kind of labels. So I'm starting out with Steve. I'm actually going to put a unit rate in between and then Mark. And then we're going to have miles and minutes. And again, we know that Steve is 4 miles in 20 minutes and Mark is 12 miles. Okay. Now, the idea of, and again, we're still looking for the same thing. So we're still looking for how many minutes did Mark travel. Now, the idea between a unit rate, unit meaning 1, is a rate in which one of the, either the numerator or the denominator, one of the components is 1. Typically, you're going to want your 1 between the two values. So that means I want my 1 to be right here. Okay. And then I'm just going to use kind of the factor of change or the fraction strategy, however you want to think about it, to change my ratio from 4 to 20 to something with a 1 and then go to 12. So what I'm going to do here is I'm going to take the times 4 to, I'm going to take divided by 4. I'm going to take 4 divided by 4 in order to get 1, and 4 divided by 20 in order to get 5. And then in order to go from 1 to 12, we're going to multiply by 12. And we do that top and bottom, and that will get us the 60 minutes that is here. Okay, so unit rate just means that I'm getting this category here in the middle where I'm going to, one thing I'm making 1. So usually we divide one of the two things by its value to get a 1, and then we multiply by whatever we need to get to the next one. So that's your unit rate strategy. And then lastly, if I set this one up, starting out the same way, this is a classic technique that you think about when you're thinking proportions. So you have Steve and Mark. Notice it's the same 4 labels every time. Miles and minutes. Only now I'm setting up two equal fractions, equal ratios in a proportion. So I have 4 and 20 for Steve, and I have 12. And this time I'm going to put an X in there to represent my space for Mark. Because what you're going to do now is, using an algebra strategy, you're going to cross multiply. So we're going to multiply these two and multiply these two. And so when you do that, you end up with 4x equals 240. Right? And again, essentially all you're doing is you're solving the equation that I set up. So you're multiplying by both denominators to clear your denominators, and then you're dividing here. So the next thing I would do to solve for x is to divide by the 4. And that will give me x equals 60 minutes. Okay. Now, when do you use each strategy? Well, typically, if my numbers work out nicely, I like to use factor of change. I almost never, unless required to, use equivalent fractions, because it's exactly the same as the factor of change. It just involves fraction bars. So if I don't need to write them, I choose not to, but you can. I often don't use unit rate unless it's something that we typically talk about in terms of a unit rate, like speed, miles per 1 hour, or dollars per 1 gallon, or something like that. I typically don't use unit rate strategy. If the numbers are not nice and compatible, then I go to cross multiplication so I can get my values that I need. Okay, so these are the 4 strategies that we're going to move forward with. So regardless of the strategy, keep in mind that you've got to have 4 labels in the quantities in the problem to receive full credit. And we're going to show you in the next part of the video how we do this in multiple situations.